not on the review, but it will be on the test. Okay? Alright, so tell whether the relation is a function. For those of you that I helped on this yesterday, what we did is we drew a little chart with the input on one side and the output on the other. And we labeled it. And we did, okay, well the input was -5, the output was -1, -3 and 2, -1 and 0, 1 and 3, 3 and 5, 5 and 6. And there was only one output for each input. There was no duplicate inputs. Can we have a duplicate output? Yes. What we can't have is that we put in -5 one time and we get 1, and we put in -5 another time and we get 2. So if you have the same input twice, then it can't be a function. But this one can be because there's no duplicates in the input side. So this is a function. So yes, or function, or however you wrote that. Now on this one, same thing. Do we see any duplicate input numbers? No. Now all the outputs are the same, but is that okay? Yeah. This line right here would look like this. On a graph, it would look just like this. Because y equals 2. It doesn't matter what x is. Y equals 2. And that's a horizontal line, which is a function. Okay? So, but if it was flipped, if all of the inputs were the same number with different outputs, then it would be a line like this, which is not a function. Again, the slope of a line like this is 0. The slope of a line like this is undefined. Okay, which correlates to if it's a function or not. So the answer to this one would be yes, it is also a function.
So basically, what I got mixed up was that I thought like we used to have a single output. So
It's input that matters. Okay, so it's input that matters. And if you guys need review on this stuff, this is 11.1. And I think, I can't remember if this is 11.1 or 11.3, because we skipped 11.2. Okay? Yes.
When you go over, like, can you go over with us like on the what are the values and integers?
Yeah, that'll be something that we do after this test. Yeah. Okay, number 3. Again, I kind of prefer the T-chart. So some of you went through and you did the T-chart like this. And you said, okay, well they're wanting me to replace x with -2, 0, 2, and 4. And then here's my equation right here. So I'm going to replace, now in order to get this, the easy way to do this is put this in function form first, which means get y by itself. Which means we're subtracting 3x from each side. So we get y equals 7 minus 3x. So now what we're going to do is we're going to go through and we're going to replace x with the numbers they told us. The first number to replace it with is -2. So then I'm going to solve this. What is 3 times -2 is -6. 7 minus -6 is the same thing as 7 plus 6, which is 13. So when I replace x with -2, y ends up being 13. Now I got to do it again, except this time I'm replacing x with 0. So when I replace x with 0, I end up getting 7 plus 0, which is 7. Okay, and then I got to do it again, and I'm replacing x now with 2. So, oops.
Wait, how did you get 13 out of negative?
Oh, because it ended up being a double negative, so we added the opposite and got positive. So now I've got 7 minus 3 times 2, which 7 minus 3 times 2 becomes 7 minus 6, and 7 minus 6 is just 1. So when x is 2, y ends up being 1. And then the last one, I go through and I replace x with 4. Oh no, not this. So now I've got 7 minus 3 times 4, which is 7 minus 12. 7 minus 12 is -5. So those should be your values for that. Now it doesn't tell us to graph it or anything else like that. It just tells us to fill in the values. So that would be how you can do that one. Now number 4 says rewrite the equation in function form, then tell whether the ordered pair is the solution of the equation. So the first thing to do is get y by itself. So if I've got 4x plus y equals 7, to get y by itself, I've got to subtract 4x from each side, and I end up with y equals 7 minus 4x. Or you could have written y equals negative 4x plus 7. Same thing. These two are the same thing. Now what I need to do is I need to go back and I need to replace x with 3 and y with negative 5 to see if this is true. Is negative 5 equal to 4? Negative 4 times 3 plus 7. So I'm just asking a yes or no question. that's just a flat line. It doesn't slant at all. Okay, so this one is negative. This one is 0. And then if I asked you to draw a undefined slope, it would just be a straight drop, like you were side to side. All right, so this is undefined because you're gonna have to do this on the test. These will be 4 different problems. Okay, 0, undefined. All right. On this one, same problem, kind of problem. Identify the x-intercept and the y-intercept. Here's where it crosses the y-axis, because that's labeled y, and here's where it crosses the x. So in order to label these points correctly, the y-intercept is where it crosses y, and what point is that?
0, 3.
0, 3. And again, does it matter? Does it matter what order I put this in?
Yes.
Yes. I can't put 3 zeros. 3 zeros right here. Now what about the x-intercept? It would be negative 3, 0. Could I put it the other way around? No. So it matters which order you put it in. Huh? Oh, it's negative 2. I'm sorry. Negative 2. Negative 2. All right. Now, number 9 says find the slope. Yes. Since it's on the graph, they want you to indicate the ordered pair. So make sure that you actually write out the ordered pair. And I kind of want to see you do that too, just so that I know you know how to put it in order, which number is x and which number is y.
If it is one on here, is it just count as 1, or is it count
Like you just missed y and not x. It would be half. Okay, does anybody remember the formula for slope? Yeah, rise over 1. So if I've got 2 ordered pairs, what was that formula? It had x's and y's in it. Yep, okay, I heard it. y2 minus y1, which indicates the horizontal change, right? Horizontal change, which is we call the rise. And then over x2 minus x1, which is the, wait, I wrote that backwards. This one's the vertical change. My bad. Vertical. And this one is the horizontal change. Okay. So I'm going to go through and I'm going to label this as x1 and this is y1. This is x2, this is y2. So I'm going to take y2, which is what number? Minus y1, which is what? 8. Over x2, which is what? Minus x1, which is what? Okay, now positive 3 minus positive 8. You've got 3 and you lose 8. Negative 5. If you've got 1 and you lose 3. And then a negative divided by a negative ends up being positive. So our slope would be 5 over 2. Now 10 and 11, when it asks you to rewrite in slope-intercept form, we're doing the same thing as we would if we rewrote it in function form. Meaning we're getting what by itself? Y. We're getting y by itself. So to get y by itself on number 10, we've got to subtract what? We subtract 3x from each side. When I do that, I get y equals negative 1 minus 3x, which in true slope-intercept form, we want the term with x to come first. So 3x minus 1. So that's how we would put it in slope-intercept form. I would take either one of these answers, though. Okay. Number 12, what would I do first? I mean, number 11, what would I do first? Subtract 12x from each side, and that would give me negative 3y equals 15 15 greater than or equal to 16? No. Okay, and then we've got to do it again, and this time we're replacing x with 8, and we're replacing y with 4. 7 times 8 is what? Minus 2 times 4, which is that greater than or equal to 16? Is 48 greater than or equal to 16? Yes. Is number 16 the same? Oh, it's the same equation, but they just didn't put it. Okay, so we'll do it one more time. Replace 7 with 4, and replace y with 6. 7 times 4 is 28, minus 2 times 6, which is, oops, I've added. 2 times 6 is 12. Is that greater than or equal to 16? So 28 minus 12 is what? Is 16 greater than or equal to 16? Yes. And then 17 and 18 are where we graph. Now, are those already in slope-intercept form? Yes. So all we have to do is graph them. So again, I'm going to draw a rough graph over here. Okay. So yeah, remember if the original inequality is just greater than or less than, we use a dotted line. And then if it's greater than or equal to or less than or equal to, we use a solid line. So
Does it like half off if you do the dot on the side?
okay. So in number 17, what is my y-intercept?
The right person.
0, -3. So I'm going to go down 1, 2, 3. So there it is. Now what's my slope? No, number 17. 4 over 1. So that means what? I'm going to rise 4. 1, 2, 3, 4, run 1. Rise 1, 2, 3, 4, run 1. And so there's my line. Now am I going to use a solid line or a dotted line? Dotted, because of the original inequality. So, sorry, it's not really a straight line, but you get the point. It's supposed to, if I was actually graphing. Now, can I test the point 0, 0? Yeah, I can, because it doesn't pass through that. So I'm going to test this right here. Now, if 0, 0 works, what do I do?
You color in this.
I color in that side. If it doesn't work, what do I do? Color in the other side. So I'm going to replace both y and x with 0. Is 0 less than 0 minus 3? Is 0 less than -3? Okay, look at it on a number line. Does 0 come to the left of -3? Is it less than -3? No. So since 0, 0 doesn't work, I would take my highlighter and I would shade